Hi, this is Janossy. In this short video, I'm going to show you how a couple of different programs in Chapter 1 in the Java Please workbook compile and run. I'll run through this rather quickly just so that you have kind of a preview of what's going on with those programs. What I'm doing right now is opening up this folder named J, which has these programs in it. Since we've already looked at the A0 program, I'm going to be looking at programs A1, 2, 3, 4, and 5 in this short video. In order to do that, I'll put this window down here. I'll take a look at this program by doing Edit, and I'll leave this window up here. We can see what this program is all about. It's a little bit bigger than the Hello program because this one's actually defining three numbers here, or at least two numbers and a place to house a third, and a little beginning statement, an addition statement where these numbers will be added, and then the sum, which is going to be placed here, will be output. And that's as much as the program does. Once again, I've got here a prep file, which, if I open this up, is similar to the prep files you've seen earlier. It simply uses the Java compiler to process this program. And these two statements are simply in this little control file to tell Windows where to find the Java compiler and where this code is actually stored. So in order to run this, I'm going to open up the command prompt, and here I'll change to this folder so that I'm in this folder where this code is, and then I'm just going to say this command file name right here. And you realize since the compiler didn't give us any kind of a complaint, there's no errors detected in the program, then I can at this point run the program by using this control file. And the only thing done here after these statements that once again tell Windows where Java is located is just to use the Java runtime environment to run this without the name Java so that it actually appears as this. That's the default then. This is the code that was output by the compile. We just don't code class after it because it's assumed to be class. So if I go here now and I enter run A1, we now have the execution of this program, and this statement A1 add program starting is being output right here. This one adding these two values is being output there. The sum is being output by this statement, and this is simply this message that the program ended normally. That's as much as that program does. I will close that. Now what I'll do from this point on is simply look at the programs themselves. So we don't have to spend time looking at the prep and the run files because they are very similar. They simply name a different program in each case. Here we have something that's going to do a loop. These statements here establish a condition that will be tested before these actions are taken. And until this condition is satisfied, this is going to continue to loop. So let me go here, clear that screen, and I'm going to prep A2, and the program compiles properly. Now I'm going to run A2, and here we see many lines of output, all generated by this one loop, because it loops as many times as it takes for this to change the value on which this test is based. You can look through this code and do read the explanations in the pages from the Java Please workbook. Every one of these programs is fully illustrated and annotated and explained as to the different elements of code, such as this while statement, which is used in this one. Let's do this. Let's clear that screen. Let's take a look at the A3 program. This one does the very same thing, but it uses a different way to do it. And the difference between these loop structures is explained in the Java Please workbook. I'm going to prep A3 in this case, and it compiles properly. I'm going to run A3, Ah, we have a problem. And I wonder what the problem is. Oh, well, you can see what I've done wrong. Look at this. This is saying in this command file, I really do have to look at it because I've got a mistake in here. It looks like in this command file, I've made a mistake. I've stated a program name that doesn't exist. And that's what all of this mumbo jumbo is telling us. Exception in this thread, an execution of something here, this one, it can't find because, of course, the program really is named A3. So I'm going to save this in its corrected form. Let's hide that now. The program code isn't the problem. The problem here is that I tried to run something that doesn't exist. Run A3. If you carefully compare this to the output of the A2 program, you'll see that the program here does exactly the same thing but uses a different looping structure. Let's clear that screen. Let's do this. Let's take a look at the program A4. And once again we see a different looping structure, this statement 4, and this more complex statement of a condition that the loop is based on. This will, once again, accomplish exactly the same processing. Let's do this. Let's prep A4. This code compiles properly. Let's run A4. And it does exactly the same thing, yet again a different code structure. These three different ways of accomplishing a loop each have a different purpose. They serve a purpose in programming in different situations. That's as much as I'll say about it right now. This part of Chapter 1, the first section of the Java Please workbook, the pages that I've given you in CSC 200, explain why these things are different and what the purpose of each of these is. That first chapter also explains the three programming structures: sequence, selection, and iteration. Iteration means looping, and these last three program examples have shown you three different ways of accomplishing iteration. Now, let's do something interesting here. I'm going to close this for this program. I'm going to look at the A5 program, which is named max-min. This program's more interesting than the others for a couple of reasons. First of all, it generates random numbers. There's a function that we can tap into that will generate as many random numbers with whatever value range we would like to have them be. Here I've taken numbers up to 1,000, that is 0 to 1,000. What I'm going to do with this logic, which introduces selection statements, the if statements here, of these random numbers, I will generate 20 of them. And I want to find out which one of that series of numbers is the biggest and which one's the smallest and where in the list it occurs. Now think about this. This is kind of interesting. These numbers are going to come at me one at a time. If you were actually manually trying to decide which of 20 numbers were bigger, you might spread them all out on a table and go back and forth and look at them and then eventually pick out the biggest one. But what if you were just being given the numbers on index cards, one number on each card, you got to see one card at a time, and then you had to turn it away and couldn't see it anymore and take a look at another number. 20 cards are going to come at you one card at a time. How would you then determine which the largest number is? Think about that. That becomes an algorithm. If you can think about a process for doing that successfully manually, then you can implement it in code to make the computer do the same thing. There's nothing magic about that. It takes a lot of thought to develop that algorithm and make sure that logically it's correct. Let's see what happens here. That's why this program is more interesting than some of the ones that have come before. And since I expect the output's going to be a little bit longer, I'm going to make that window bigger. So first I'm going to prep A5, and it compiles properly. Now I'm going to run A5. And much more comes out of this. So what is it telling us? Here it generated 20 numbers at random. Which one of these numbers is the biggest? Well, it found the maximum is the 16th one, and the value is 982. The minimum is the 8th one, and it's 1. And so it says this. It had to determine this, seeing these numbers one at a time, keeping track of which was which, and picking out then the largest of them. If you read through this program and the explanation of it in the Java Please workbook pages, you'll see what kind of logic this program is actually using to do this. What you see here then is just some simple Java that implements that algorithm. So an algorithm is a way of accomplishing something that's unambiguous and it has a stated ending. In this case, the ending is after the 20th number, the program will end. An algorithm is only valid if it does define some sort of an ending point. That's as much as I'll talk about here, just in demonstrating these programs. With this third video, you should be ready to approach the work in Capstone Project 4, and you now have a way of actually accomplishing it. There is another video coming up in which I'll show some other programs that go beyond what you need to do for CSC 200. The reason I'll show you that is just to show you how interesting things get when we write computer programs. We figure out the logic for doing something first, and then we can do some very neat things that are very powerful because the computer can execute these instructions so rapidly. So take a look at the fourth video when you get a chance.